Hey everybody, it's me Unhan again. I know I haven't uploaded a video for quite a long time, but it doesn't matter because today I'm here and I'm gonna be showing a special video, and that it involves like I'm not gonna review the surprise yet, but it's actually very interesting. And I actually got this problem from Brilliant, and I hope you will enjoy this video. So see you. Okay, so over here it states in the problem that we have to find the Maclaurin series for A, the natural log of 1 plus A, 1 plus x, and B is arctangent of x. You may know that these functions are actually very familiar, and you probably know their sequences by now. But let's say you didn't know what they were. So we could probably use a method called first we have to know what's a Maclaurin series. I hope you know about Taylor series. It's very important. And anyway, if you do not know, then might as well search it up. I cannot explain this video yet. I'm actually planning to do something else. Anyway, this is actually a Taylor series. Sorry, this is supposed to be there. It's a Taylor series centered at 0. Not 0 factorial, 0. So we could probably do this we could probably find the derivatives over here, but we do not want that. Well, we could do it, but it's kind of messy, right? It's kind of messy. So all we need to do right now, let's try to consider a different problem, but also involves that. I will come to that point later. Sorry, I will come to that point now, but it doesn't matter about which problem to choose. Just try to see what they are related to. Anyway, I'm going to be changing the problem over here. Okay, wait a second. Oh. Okay, that's better. So anyway, now all we have to do is just to consider another problem, as I told you. Now I'm gonna write down the problem. I know it may seem confusing to you, but don't worry yet. Find the integral of... This is getting exciting. 1 over 1 plus x to the power of n. It seems very confusing, but I'll make it simpler to you. In summation form. Okay, this will actually lead to our answer to our original problem. But first, let's find out the answer to this one. And you still gain extra knowledge while you're doing it. So, to find this integral, you can actually use sort of a method. Okay, for me, I actually already have a method. And do you know what that method is? It's not partial fractions. It's not those confusing integration by parts stuff. And guess what it is? It's series expansion. Or should I say also Taylor series. Or Macu Clue. Okay, whatever. It's just Taylor series. Maclaurin series is also somewhere the same. You can also use this method, and that is how that is sort of related to the previous problem. So over here is I guess you should already know one of the Taylor series. So I'm gonna help you out on this one instead. Okay, 1 over 1 plus x. Let's try to find the Taylor series of this. But first let's consider a simpler problem. 1 over 1 minus x. As you can see, I've actually converted the plus to minus. So actually it will be simpler to do this problem. In fact, some of you might already know the answer. So anyway, this is actually equals to, I'm going to use long division over here. Over here, I'm going to divide. No, actually, you know, I'm not going to use long division. I'm just going to do my memory, okay? It's 1 plus x squared plus x cubed plus x to the 4 plus x to the 5 plus, and it goes on forever and forever. Never stops. And yeah, I can still write it as a summation, obviously. N equals to 0. No, I'm going to use k. K is equals to 0 all the way up to infinity of x to the k. But you must remember that the absolute value of x must be lesser than 1. Take note that for x is equals to 1, for x equals to 1, the sum diverges, and for x equals to negative 1, the sum doesn't converge. Doesn't converge. But it does not diverge either. Okay. Actually, it would get 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. But anyway, we still have to wait. So anyway, the restriction is still this. Using the restriction, we can not using the restriction. Using the summation, we can actually find. Wait. Oh gosh, what am I doing? Anyway, sorry. This summation is negative 1 to the k multiplied by x to the k. No, sorry. Yeah, my gosh, what am I doing? I'm so careless. It's x to the k. Just k, x to the k. Anyway, now we can actually find the value of this. And in fact, all we have to do is just to make it simpler. 1 over 1 minus x. So therefore, all we have to do right now is just to change it. 1 minus x. Oh wait, 1. Okay, yeah, I'm gonna make it simpler. 1 plus minus x plus minus x to square plus minus x cubed plus minus x to the 4th plus minus x to the 5 plus and so on. Can you see it? Yeah, you should be able to. And from here, all we have to do is just simplify it. It's 1 minus x plus x squared minus x cubed plus x4 minus x to the 5th and plus, and you go on from there and you don't stop. Again, you can write it as a... Sorry, something happened. I don't know what. I think I can record only a maximum of 10 minutes. Okay, so anyway, all we have to do now is just to continue from there. And we can write an infinite summation for this summation. It's equals to this. K equals 0 up to infinity of yet negative 1 to the k x to the k again. Okay, never mind. Okay, it doesn't matter for the restrictions for now, but right now all we're focusing on is this. Now we can actually start to find the answer to our original problem. As you can see, we use this negative x over here. You can actually use this negative 1 minus negative x over here to find out the reciprocal of 1 plus x. 1 plus x. So therefore, from there we actually are able to like find a different summation. And remember, the first one is in summation form. So all we have to do now is just to substitute it on again. So I'm gonna erase this again. My gosh, I don't know where it does. I'm gonna erase it again. Anyway, my gosh. Okay, so anyway, now all I have to do is just to find 1 over 1 plus x squared. We already know this is... Okay, right. Okay, over here, we can actually just substitute 1 over 1 plus x squared. So we can actually just group it. So all we have to do now is just substitute again. 1 plus x squared. Oh, sorry. 1 minus x squared plus x to the... Sorry. Wait, plus x squared minus x squared cubed plus x squared to the 4th minus x squared to the 5th plus and so on. And it's actually quite simple to simplify this. It's just 1 minus x squared plus x to the 4th minus x to the 6th plus x to the 8th minus x to the 10th plus and so on. In fact, I don't even need to do that. I could just write that immediately. So anyway, once we got that value, we can start to extend it for 1 over 1 plus x cubed. I no need to explain it again. I can just directly substitute. 1 minus x cubed plus x to the 6th plus minus x to the 9th plus x to the 12th minus x to the 15th plus and so on. Now we can actually find a generalization for 1 over 1 plus x to the power of n. Over here, we can already find it. 1 minus x to the power of n plus x to the power of 2n minus x to the power of 3n plus x to the power of 4n minus x to the power of 5n plus dot dot dot. So from there, I can actually write a different summation now. This summation is the sum from k equals to 1 to infinity of, guess what it is? It's actually kind of, again, it's simple. It's actually the summation for -1 to the power of k. Then we have x to the kn. That is literally the sum for that. Now you can see that it's written in summation form, right? Now we can actually find the integral of it in order to find that. Okay, anyway, let us all do it. Let's erase it again. My hand is very sweaty sometimes, so you can literally erase this kind of stuff. Okay, okay, anyway, now all I have to do is just to find the integral. The integral of 1 over 1 plus x to the n dx is equals to the integral of the summation from k is equals to 1 to infinity of -1 to the n multiplied by k. It's just the k. And after that is x to the power of k and also, oh my gosh.
What? Is this a live stream?
No.
Or you're just...
And anyway, come here. This is my sister. Down.
Down?
Down.
Ah, what do you mean by that?
Okay, this is my sister.
Hello.
Please subscribe to her. Okay?
Hello. Why do you know you had that thingy?
Never mind. Okay.
It's so awesome.
Anyway, now all I have to do is just add a dx. And yet, since it's a summation inside an integral, there's actually another way to find this. We can move the summation outside. So we can use the summation from k is equals to 1 all the way to infinity of the integral of -1 to the k x to the kn dx. See?
My phone.
Yeah, that's a new phone. My phone is a Samsung Galaxy now. I changed it.
This is firstly his phone, and then he just got a new one. So I just have this one.
Okay, so anyway, now all we have to do is find the integral, and yet it doesn't really matter, so it's just a constant, and we can use the power rule to find the integral. So we have this. K is equals to 1 all the way up to infinity of the actually we just need to use the power rule directly. It's of -1 to the power of k x to the k n plus 1 over k n plus 1, and we just solved our we just solved our final problem. See, we just got our answer, but we still haven't solved the first problem, which is to find the Taylor series center at 0 for the natural log of 1 plus x and arctangent of x. So anyway, applying the first problem right now. See, now we have to apply it to the first problem. to the first problem. Okay, applying to the first problem is actually find the Maclaurin series for, firstly, the natural log of 1 plus x and the arc. It happened again. Okay, so anyway, it's just for natural log of 1 plus x and the arctangent of x. You will actually notice that these two problems are related. Why? Because this one is the integral of 1 over 1 plus x dx, and this one is the integral of 1 over 1 plus x squared dx. So actually, if we want to find the Maclaurin series, we can actually just plug it into this one. So just erase this first. For this one first, all we have to do is to do this. The natural log of 1 plus x is equals to the summation from k is equals to 1 all the way up to infinity of -1 to the power of k x to the power of k n. But what is n? N we already found out that it's 1 because it's just 1 over 1 plus x to the 1. So we just plug in 1, which is just k. Then we add 1 over k plus 1. And thus, this is equals to...
Die.
My gosh. This is equals to...
Die.
Stop it.
Fine.
Okay, first it's x. The first term is x, we already know. Because this one is just as... Oh, wait. Sorry, this one I've been making a mistake. They're all 0. Yeah, literally all 0 from there. Then it's supposed to be from 0. Okay, equals to 0. Okay. Okay, now it's x plus. Then we have to subtract. We have 1/2 x squared. Because we have this one 1 and we have 2. Wait, this one we have 1, 2. After we have 1, 2. And yeah, it's a minus, so it's like this. Then we have to add the next term, which is literally 1/3 of x to the 3, right? Yeah, correct. I'll just move it down like this. Whatever. Okay, we can just do that. Okay, so therefore from here we just continue. Minus 1/4 of x to the 4th. Plus, and we go on forever. And this by itself, it's already the Maclaurin series for natural log of 1 plus x. Okay. Now we need to find the different sum.
For my storybook idea, should I use any of these?
I don't know. Okay. Anyway, now we have to find a different one, which is the arctangent.
Why are you using blue only?
Oh, never mind. Arctangent of x.
I think
Because the sum from k equals 0 to all the way to infinity of -1 to k x to the 2k plus 1. Actually, it's just 2k plus 1. Then we have, it all over 2k plus 1. Then from here, this is equals to, okay, wait a second. From here, this is actually equals to, because we start with an x, right? Then we have the, in fact, this is sort of like the odd numbers below. X minus, okay, sorry. X minus 1/3 of x cubed plus 1/5 of x to the 7th. Oops, sorry, x to the 5th. And then minus 1/7 x to the 7th. And you go on from that forever. And yes, indeed, this really is the Maclaurin series for arctangent for x. The arctangent of x. So it really is a miracle that these two functions are related. Okay, so far what we learned already today is these 3 things. These 3 things is that the natural log of x is equals to x minus x blah 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 blah. And you also learned that the arctangent of x is equal to blah this blah 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 blah. And lastly, this is the biggest impact of all. This is actually very useful. And I hope you enjoyed this video. And I'll see you next time. Bye.